This is the sulfuric acid solution. These are the electrodes. A charged lead-acid battery has lead dioxide on its positive plates and lead on its negative plates. The electrons are transferred through the circuit from the negative plate to the positive plate. As the lead loses some of its electrons, sulfate radicals from the electrolyte join some of the lead to form lead sulfate.
This is the process when electron transfer from negative to positive.
As the electrolyte loses its sulfate radicals, the remaining hydrogen ions will take on the oxygen ions from the lead dioxide, converting the electrolyte into water and the lead dioxide into lead. As the electrolyte loses its sulfate radicals, the remaining hydrogen ions will take on the oxygen ions from the lead dioxide, converting the electrolyte into water and the lead dioxide into lead. Sulfate radicals from the electrolyte will then combine with the lead on the positive plate to form the lead sulfate. Thus, the chemical reaction leads to lead sulfate forming on both plates. At the same time, molecules of water are formed, diluting the electrolyte. Water forming in the electrolyte as the cell discharges lowers the concentration of the sulfuric acid.
During discharging of lead cell, the negative electrode, which is merely lead itself, will react with sulfuric acid to produce lead sulfate, 2 hydrogen ions, and 2 excessive electrons. While the positive side, the lead dioxide and the sulfuric acid will produce lead sulfate and water.
These are the sulfate radicals.
When a discharged lead-acid battery is being charged, electrons are forced into the cell at the negative terminal. This drives the sulfate radicals from both the positive and negative plates back into the electrolyte, where they combine with the hydrogen ions from water to form sulfuric acid. Oxygen ions driven out of the water will unite with lead ions on the positive plate to form lead dioxide. With this, the cell is back to its charged condition, and this should be reflected in the specific gravity of the electrolyte. The SG of the electrolyte should be between 1.265 and 1.275 at 80 degrees Fahrenheit. Lead-acid batteries are mostly used for emergency lighting and in case of power failures. They are also used to supply heaters, submarines, high current drain applications, and sealed batteries for portable equipments.
There are many ways to battery maintenance, one of which is batteries should be clean. Cable connections needs to be clean and tightened. Serviceable battery and only needs to have fluid level, checked regularly, and only at full charge.